Okay, we're going to look at the Prealgebra Chapter 11 practice test. The first three problems are proportion problems, and let me remind you, if two fractions are proportional, then you can cross multiply, and for example, 7 times n is going to equal 4 times 21. If they're not proportional, then that would not hold true. But these are three proportion problems. So we're going to solve for an unknown variable using cross multiplication. So 4 times 21, which is written here, equals 7 times n. And remember, to get a variable alone, you undo what's happening to it on its same side. It's being multiplied by 7. So to undo that, we divide both sides by 7. I wrote that in blue so you could see it. So put into your calculator 4 times 21 divided by 7. You'll end up with 12 equals n. Okay, the next one, looks like I worked this one out over here to the side. And notice we've got 20 plus x as our denominator here. So 13 times 20 plus x is going to be represented with the parentheses around the 20 plus x. And notice I've got the little blue lines here showing you're going to have to use the distributive property in order to solve, which means times 13 by the 20, and that was 260, and 13 times the x, so it's 260 plus 13x equals 420. And then again, you undo. First, addition and subtraction gets undone. So here's add 260, opposite is minus 260 on both sides. And then your next step would be to undo the 13 times x, which is done by divide by 13. You end up with x is about 12.3. Okay, and then my third one is shown right down here. Final answer is x equals 36. Okay, let's look at the next kind of problem. Simplify square root of 16, and it's got a negative in front of it. So in other words, you're going to take this answer, and the answer is going to end up being negative. So square root of 16 is 4. And remember, what is square root? It's the inverse operation, or backwards operation, of squaring a number. So 4 squared means 4 times 4 is 16. So when we go backwards, we find out what two numbers multiplied to get the 16, and it's 4. And 121 square rooted is 11. Okay, so estimate to the nearest integer. Now we've got some square roots that are not going to come out to a whole number, but which whole number is it closest to? Well, if you've got these what's called perfect squares, in other words, the number squared will end up being a whole number. So this is a perfect square. 5 times 5 is 25. If you've got these kind of memorized, your perfect squares, you can figure out which perfect square this is between and which one it's closest to. It's between the 5 and the 6 squared, and it's closest to the 6. So 31 square rooted is 6. The other way you can do it, put it in a calculator and then round the answer that you get. You're still going to get 6. 17 is between 16 and 25, and so it's closest to this one though, so it's about 4. 23 is between 4 and 5, closest to this, so it's about 5. Okay, the lengths of sides of triangles are right triangles. The lengths of the sides of triangles are given. Find the missing side length if they are right triangles. Okay, so I circled that. Why? There's meaning behind that. The Pythagorean theorem will work if it's a right triangle. A squared plus b squared is c squared. And remember, a and b are the legs of the right triangle. C is the hypotenuse. Okay, so I'm plugging these into that formula. 12 squared plus 8 squared is c squared. And I show my progression of solving it sideways, which is not normal in algebra, but anyway, I had to because I didn't have the space. And so the final answer, c squared equals 208, and so then I square rooted that for my final answer. C is about 14.4. Okay, this one you're given the hypotenuse in one of the legs, so we've got to solve for the a squared. And so I show the progression right down here, and my final answer, A, is about 6.7. Okay, let's look at the back. Again, we're going to deal with, can you form a right triangle? So you'll plug these three numbers into the Pythagorean theorem. You always know your hypotenuse because it's going to be the longest number. And whether these are A or B, doesn't matter if you mix those up. You just have to make sure the longest one is the hypotenuse. So I plug it in to the formula, I solve it. If you get an answer where it does not equal, then that means it's not a right triangle and your answer is no. If you get an answer like in number 12 where it does equal on both sides, it's a true statement, then your answer is yes, it's a right triangle. Okay? Now, find the distance between the pair of points. Round to the nearest tenth. Okay, so here's your distance formula. Square root of, and I kind of muffed up there, so let me read that for you. That's, you're given 2 points. So we're going to call the first point x1, y1, and the second point x2, y2. So your formula is take your second x minus your first x and square that, and add it to your second y minus your first y and square that. Then you square root the whole thing, and that'll give you the distance between the 2 points. Okay, so I show the progression of 13 and 14 here. I plugged in, now notice, when I take my x, 5, minus, the formula is minus, and I have a negative 3, you're going to have to show a double negative here. So put your negative 3 in parentheses, and a double negative means opposite of negative 3, so that means you're going to add the two together. You're going to do the opposite. So you're going to add, you end up with 8 squared for 5, take away negative 3. Then 8 minus 2 is 6, 6 squared, and here's the progression. You end up with distance equals 10, because you end up with square root of 100. Okay, the second one, I had negative 3 for my x2 minus my 5, and then over here I have 7, take away negative 6. So there's another one of those double negatives. And here's the progression of that problem. So you end up with distance is about 15.3. That's a rounded decimal. It actually went on further. Okay, for which value of n will the square root of n be an integer? So you could, if you don't have it memorized and you can't recognize it, put all these in the calculator. Square root of 45, you're going to end up with a long decimal. Square root of 15, same thing. This is the only one where you end up with a whole integer, and so therefore it's C. This one's a decimal as well. Describe the product of square root of 16 times pi. Pi is an irrational number. So you'll end up with 4 times pi, and by multiplying by an irrational number, well, what is that? Irrational is a number that can't form a ratio, in other words, can't form a fraction, and it's a decimal that doesn't terminate, it goes on forever, and there's nothing repeating in a pattern in it. So anyway, because you're multiplying by an irrational number, your answer is going to be irrational. Okay, so that's how you describe it. Draw the figure that best represents a squared plus b squared equals c squared. Well, remember, this formula, this theorem, Pythagorean theorem, only applies to a right triangle. So I drew a right triangle. All right, 18. A boat travels 6 kilometers north and turns east, traveling until it arrives at the camp store. So I drew a little picture, my boat, 6 kilometers north, 8 kilometers east. Notice, a turn like that makes a right turn. So that forms a right angle there. And then if they would have traveled directly there, so in other words, not done this turn, gone straight there, shown by the dash line, they would have gone 10 kilometers. How far did they travel east? So this is our unknown, the east. I have it written in there now, but actually it was unknown originally. I put it into the Pythagorean theorem, and then I solved for that side, and the distance east is 8 kilometers. Okay, next one. We have write an expression to prove the figure is a right triangle. So that should bring to your memory the Pythagorean theorem, and you plug in all these sides into it. Of course, your longest one is the hypotenuse, which is your C, and you end up with 25 equals 25. So it is true that it is a right triangle, And your proof is the Pythagorean theorem because it only works for a right triangle. Okay, here's a building, and using indirect measurement, find the building height. So we have a similar large triangle compared to this smaller triangle that I highlighted in red. A man is 5 feet, and this is how we sometimes find things that are too tall to measure, by indirect measurement with similar figures. So the shadow length of the guy is right here, 2 feet. Shadow length of the building goes all the way out, so you have to add 11.2 plus the 2, which ends up being 13.2. So I set up height to shadow is my proportion. So height of the man to the shadow of the man. Height of the building to the shadow length of the building. And here's the math for it. You end up with, when you solve it all, 33 feet for the height of the building. Okay, we have two similar triangles. One little one inside the big one. And you need to solve for the x. So I'm going to compare the hypotenuse to the base of each triangle. Hypotenuse of the little one to the base of the little one. Hypotenuse of the big one to the base of the big one. And notice, the hypotenuse of the big one, you have to add these two together, 20 plus x. And actually, you saw this same problem on the first page when we were doing proportion problems. So you end up with x is about 12.3. Okay, here is another proportion with two triangles, only you've got your little one, and then your second one is upside down and flipped the opposite direction. So the first thing I did was identify what's similar here. The 15 side is similar to this unknown x side. The 25 is similar to the 60. So I'm going to compare my 15 to my x and my 25 to my 60, 15, and then solve for the unknown x. And you end up with 36 equals x. Okay, now, I have something I left off your practice tests, and I plan to email the parents to let them know to look at this. It is in your notes, though, and we did go over it. It's in that first worksheet I gave you that I told you to keep for the test. But if you're given 2 points, and you graph those 2 points, see I have my -2, 4 here, and I have my 8, 8, -3. I wrote this wrong. This one is 8, -3. Alrighty, that one's 8, -3. You can count it over. 1, 2, 3, 4, 5, 6, 7, 8, -1, 2, 3. So I plotted it right, labeled it wrong. Anyway, how do you find the middle of these two mathematically? Well, you use the midpoint formula. And basically, you're going to average your two x's, so add them together, divide by 2. That's what I did here. Divide by 2. Average your two y's. Add them together, divide by 2, and then the numbers you come up with will be the numbers of the middle point. So the coordinates of the middle point is a better way of saying it. 6 divided by 2 comes out to 3, so you go over 3 for x, and then I got 1/2, so up a half for y, and notice that does look like the middle of this line here. Okay, so hopefully you'll be ready for your test Tuesday. Thanks.